Hey everyone, welcome to this explainer. Today, we're jumping right into a real WASSCE Mathematics question for 2025. We are going to totally conquer question 7 on set theory. Now, I know set theory can sometimes look like this crazy jumble of weird symbols and letters, but hey, don't sweat it. We're going to make this completely visual, incredibly clear, and we'll be looking right at the numbers every single step of the way. Let's get right into it. All right, so here's the big boss puzzle on your screen. The question states, if set M is the set of x such that x is between 2 and 6 inclusive, and set N is the set of x such that x is between 4 and 8 inclusive, and both of these are subsets of our universal set mu, where x is an integer from 1 to 10. Our mission? Find M prime intersection N prime. And we've got 4 options, A, B, C, and D. I know, it looks super complicated written out like this, right? But let's just unpack these symbols into actual workable numbers. To kick things off, we've got to define our world for this problem. In set theory, the universal set, that little mu symbol right there on the screen, is literally everything. Think of it like an entire classroom of students. Since the question specifically told us x is an integer from 1 to 10, our universal classroom has exactly 10 students in it, numbered 1 through 10. That's it. No decimals, no fractions. Everything we do in this entire problem is going to exclusively use these 10 whole numbers. Okay, next up, we need to figure out what's inside sets M and N. You can think of M and N as 2 exclusive clubs operating right inside our larger classroom of 10 students. The problem says M includes integers from 2 to 6, and because we have that less than or equal to sign, we've got to include the 2 and the 6. So Club M is made up of students 2, 3, 4, 5, and 6. Meanwhile, Club N includes integers from 4 to 8, so Club N has students 4, 5, 6, 7, and 8. See? Just listing them out right here instantly removes all that confusion from those messy inequality symbols. Now for the absolute crucial part, figuring out what M prime actually means. M prime basically is just the complement of M. What does that mean in plain English? It just means everyone in the classroom who is not in Club M. So if we take our universal set right here and literally cross out the members of M, so goodbye 2, 3, 4, 5, and 6, who's left behind? We're left with 1, 7, 8, 9, and 10. And boom, that is our M prime. Just a super simple process of elimination. All right, let's see how this exact same logic works for set N. We're going to find N prime, which is the complement of N. Remember, Club N has members 4, 5, 6, 7, and 8. So to find N prime, we just go back to our whole classroom of 10 students, and we ask those 5 specific members of Club N to step outside. Once we visually remove 4 through 8 from our list, what do we have? We're left with 1, 2, 3, 9, and 10. That right there is N prime. And guess what? We finally have all the pieces we need. So here's the grand finale. The problem asked us to find M prime intersection N prime. Now, that upside-down U symbol means intersection, and intersection literally just means, hey, what do these two groups have in common? We've got M prime on the screen, 1, 7, 8, 9, and 10, and we've got N prime, 1, 2, 3, 9, and 10. Scanning across both of these sets, which numbers pop up in both lists? Let's trace it out together. 1 is in both, 9 is in both, and yep, 10 is in both. Therefore, the intersection is exactly those shared elements, 1, 9, and 10. And there we have it. M prime intersection N prime equals the set containing 1, 9, and 10. If we look back at the original WASSCE options they gave us at the start of the problem, we can clearly see that option C matches our result perfectly. We've logically, visually, and systematically dismantled this whole thing. Option C is the absolute winner here. Give yourself a pat on the back because you just solidly solved a WASSCE 2025 mathematics question. But hold up. What if I told you there's a really cool shortcut that could save you some precious time on the exam? There's this famous rule called De Morgan's law. It states that M prime intersection N prime is actually the exact same thing as finding M union N first and then finding the complement of that entire group. Did you notice how the symbols flip? The intersection turns into a union and the prime moves to the outside of the parentheses? Let's test this brilliant little shortcut together and see if it works. Okay, let's prove it. First, we find the union of M and N. That means basically dumping all the members of Club M and Club N into one big giant group. So, combining numbers 2 through 6 and 4 through 8 gives us a mega club of 2, 3, 4, 5, 6, 7, and 8. That's M union N right there. Now we apply the complement. What is outside of this mega club in our 10-student classroom?
Well, if we remove 2 through 8 from our 1 to 10 list, we are instantly left with 1, 9, and 10. Look at that. It's the exact same answer we got earlier, but with way fewer steps. Honestly, De Morgan's Law is an absolutely fantastic tool to keep in your back pocket.
Before we move on, let's do a really quick, structured recap of our mathematical journey here so you can see the whole flow. Step 1, we defined our universe, numbers 1 through 10. Steps 2 and 3, we expanded sets m and n into actual numbers. Steps 4 and 5, we found the complements, m prime and n prime, by just removing m and n from the universe. And finally, step 6, we looked for the intersection, that common ground between the two primes, which brought us safely to our answer, 1, 9, and 10. When it's laid out step by step like this right on the screen, you realize there's no magic. It's just pure logic. Okay, let's dive into a quick challenge to really test those new skills. Think of this as a mini workout for your brain. Suppose our universal set mu is just the numbers 1, 2, 3, 4, and 5. A much smaller classroom this time. And let's say set A contains just the numbers 2 and 3. Your mission? Find A prime. Think back to what we just learned about complements. What is in the universal set that is not in set A?
Did you get it? The solution is right up here. A prime equals the set containing 1, 4, and 5. Since set A took the numbers 2 and 3 out of the universal set, the numbers left over are simply 1, 4, and 5. If you nailed that, you totally understand the concept of a complement. You are well on your way to absolutely acing set theory.
All right, let's push a little harder with a second quick quiz. This one looks a bit more like our main WASSCE question. Our universal set mu is 1 through 6. Set A contains 1, 2, and 3. Set B contains 3 and 4. Now I want you to find A prime intersection B prime. You're going to need to do this in pieces. First find A prime, then find B prime, then find what they have in common. You've got this. Let's walk through those many steps together on screen. To get A prime, we take 1, 2, and 3 away from our 1 to 6 universe, which leaves us with 4, 5, and 6. To get B prime, we take 3 and 4 away from the universe, leaving us with 1, 2, 5, and 6. Now, the final part of the puzzle is the intersection. Looking directly at A prime and B prime, what numbers do they share? Exactly. The final answer for quiz 2 is the set containing 5 and 6. Those are the only two numbers that appear in both A prime and B prime. Huge congratulations if you followed that logic all the way through. You are visually mastering a pretty complex mathematical concept just by breaking it down into simple, manageable steps. I want to leave you with a bit of a provocative thought today. Look back at that last quiz. Could you apply that De Morgan's Law shortcut to quick quiz 2? Try finding A union B first and then taking the complement of that. I guarantee you'll find the numbers 5 and 6 staring right back at you, completely validating all your hard work. Mastering these visual concepts is the absolute key to exam success. For more deep dive, step-by-step WAEC, JAMB, and GCE explanations just like this one, rush over to QandAHelp.com. Thank you so much for hanging out and learning with me today, and keep on practicing.